So I want to transition a little more to right triangle problems. Yeah, I'm going to transition more to right triangle problems. I've got a bunch here that I'd like to look at with you. That's how we're going to spend our next two videos, is looking at some of these. And I believe that this is going to be assignment 47. Assignment 47, word problems 1. All right, so what do we got going? The Shanghai World Financial Center. And if you haven't seen what this looks like, you should probably Google it because it's pretty amazing. It's a building, and if you stand, well, I guess it's the Shanghai World Financial Center. There's our building, and if you stand 1 mile back, i.e. 5,280 feet back, the angle of elevation to the top of the building is 17 degrees. Okay, so let's review. That's an angle of depression. That's the most common wrong answer as to where the angle of depression is. That's the angle of depression. That is not the angle of depression. That is not the angle of depression. You may think I've said it enough times. Trust me, I've taught this class as long as you've been alive, and I know that even though I'm saying now for a third time that is not the angle of elevation, angle of depression, many people on the next assessment will claim this to be the angle of depression. This is the angle of depression. You're looking your eyes straight out. You depress your eyes to see down to that point, if you're on top of the tower. But if you're on here, standing a mile back, then this is called the angle of elevation. And because parallel lines cut by transversal, you know that the angle of depression and angle of elevation are congruent. Which is another thing, like if I know these things are supposed to be congruent, then why am I saying that these two things are always equal? Because that would always make these to be 45, 45, 90 right triangles, and they're not. So, yeah, don't go down that road. Okay, but what we want to know is how tall? We want to know the height of this building. Well, if this is 17 degrees, we know that this is 17 degrees. What trig function do you think we should use here? Do I know the hypotenuse? No. I'm looking for the height of the building. I only know this side, 5,280 feet, or 1 mile. And generally speaking, we don't measure buildings in terms of miles. So I think I'm going to use this number instead, the 5,280 feet. And I agree. I'm looking for the opposite side. I know the adjacent side. And it sounds a lot like tangent of that angle should be height over 5,280. And so how will I solve that equation for height? That's right. I'm going to multiply both sides by 5,280. You know, just like I said before, to clear out that denominator. We can do that when we have an equal sign and when we're solving. So h, the height of the building, is 5,280 times tan 17. Okay, so 5,280 tan 17. And I end up with 614.258 feet for h. Okay? So really, this isn't, you've been doing problems like this since at least geometry class. This is one triangle. It's pretty straightforward. So I would also say many of you get really concerned, really anxious, really upset with word problems because there's a lot of information to process, I understand. But since most of your adult life is going to be filled with you living word problems and trying to figure them out, this would be a good time to sort of, amble up, give it a sniff, and see if you can make it part of your life in a more comfortable or less anxious way. So, how about another one? Ooh, the Pentagon. Yeah, so we have this building. Washington, called Pentagon. And unlike my Pentagon, um, yeah, that's almost regular. The sides are all equal. These angles are all equal. We know that the Pentagon in Washington, 921 feet on each side. And what I'd like to know, because for a while this building was called the world's largest office building. And so I'd like to know total interior area. Mr. Cooper, are you asking me to find the area of the Pentagon? It's true. I am asking you to find the area of the Pentagon. And hopefully you did that with your geometry teacher. I will say that there's going to be some knowledge that we need to bring to these regular polygon area problems. And the first of which is that line that I'm using AP for, and the cool thing about being dyslexic is, this is apothem, or is it apothem? I think it's apothem. But one of you might want to look that up and put a message below the video. That's our AP. And the apothem goes from the center of the object perpendicular to one of the sides. It does cut that side into two equal pieces. And this, which is called actually a radius, because if you draw a circle here, then from the center to the circle is the radius. Yeah. So that one can be radius, and what we see here is this is half a side length, and there's another half of a side length. So I'm going to pull that little triangle here, because we're going to be seeing this triangle a lot. We've got half a side length, we've got a radius, and an apothem. Okay? Nice. Still some more stuff we need to know, or we need to remember. Theta and phi. You're going to need to know one of those, and I'll show you how to figure it out in a minute. The last thing that we're going to need is the area formula. And the formula for area of a regular polygon, area equals 1/2 times perimeter times apothem. I really want to say apothem. So how do I find these things? Well, perimeter, because this is the thing I'm looking for, right? So I must know how to find these things. Perimeter. Well, Pentagon has 5 sides, and each of those sides is 921 feet. So perimeter, 5 times 921. And we end up with 4605. Okay, so I've got the perimeter. I just need the apothem now. I know that this is half a side length, and a whole side length is 921. So if I have 921 divided by 2, this is going to be 460.5 feet. But I still don't have enough information, do I? Look, I've got one side, I'm looking for another side. I don't know either of these angles yet, and I certainly don't know the radius. So I couldn't use these two in the Pythagorean theorem to find that, because I don't know that. And I can't use tangent with this, because I don't know this. Well, it turns out, in geometry, you learned how to find both of these. Or, I like to believe you learned how to find both of these. So let's go back and look at what we know about the area, about the angles in regular polygons. So, I'm wondering if I should derive the formula for you. Yeah, no, I don't think so. But if any of you wants to know the derivation of either of these, let me know. So, theta. Theta is this angle 2. Now, what's this whole angle? Well, I remember the formula being n minus 2 times 180 divided by n. This formula gives me that big angle. And because this radius cuts that angle into 2 equal pieces, I have a 2 here. Okay, so that's my formula for theta. And, you know, I feel pretty comfortable using this formula. A lot of students don't. Some students actually like to do this, where they have 180n minus 360, and then they divide each piece by 2n, and so they get 90 minus 180 over n. N is the number of sides. And it's not 3. We're talking about a pentagon. So in our problem, n is 5. Okay, so I'm going to plug a 5 in for n. So I can plug my 5 in for n here and here, or I can plug my 5 in for n here. 180 divided by 5. Well, that's going to be 3. 3 times 5 is 1530 is 6. So we've got 36 times 5, 150 plus 30 is 180, yes. So I get that this angle is 36 degrees. Doesn't quite feel right. Oh, it's 90 minus 36 degrees. Oh, that feels much better. 54. So I get 54 there. And likewise, if I plugged in my 5 sides here, 5 minus 2 is 3. 3 times 180 over 2 times 5 is 10. And so I get 3 times 18, which is 54. I don't think that's a big deal. That's my way of thinking about it, but yeah, most students hate that way. So here's what most students do. They say, Mr. Kruger, I'm going to find phi. Is that okay? Yeah, because they remember that all the angles here add up to 180. And so I can think of this as a bunch of triangles, all sort of angle plus angle plus angle plus angle. I guess I should have drawn another one here. Like that. Okay, so we've got all these angles that we're drawing, and if we add them all up, guess what? We get 180 degrees around that point. But that would give us this, and we don't want that. We want just this one, which is half. So again with the half. Anyway, what I'm thinking of here is that all the way around, 360, divided by the number of sides, divided by 5. But wait, that gets us this whole angle. So we want to divide that in half. Wait, the number of sides, there we go. And so I have 180 over n. And students year after year say to me, Mr. Google, that's way easier to remember. Sure, I agree with you completely. That is way easier to remember. So why is it that I like the other way more? Why do I like finding this one more than finding this one? Well, it turns out that generally speaking, when we use this angle and tangent, we'd have tan 36 equals, what was 921 divided by 2? It was 460.5 over adjacent. This setup is hard for a lot of students. They don't know how to deal with this variable in the bottom like that. If we go with this angle, tangent 54 is apothem over 460.5. So, the variable is on top. The student only has to multiply both sides by 460.5 to get that apothem. But here, I see students do this. I see them take 460.5 and they divide each side by 460.5. And they say that's the apothem. But no, it isn't. That's 1 over the apothem. And most students, yeah, of course, you could just, do the reciprocal of this, but that's not what most students do. Most students say that the apothem is this, and therefore the rest of their calculations is wrong. I really don't care if you find phi or theta. You do have to find one of them. And the solving is always harder when you find phi. But boy, that is a simple formula. And what was the other formula we had? Theta. Theta was n minus 2 times 180 over 2n. Yeah, that's that angle down. And again, n is the number of sides. You might want to write that down because a number of people forget what n represents by the time we get to the assessment for this unit. Okay, so we're not quite done yet, right? We just now know how to find those angles, and we now know that the apothem is going to be tangent 54 equals apothem over 460.5, and I'm going to multiply both sides by 460.5. So those go away, and that's my apothem, which is 460.5 times tan 54. Oops, let's see, I have some things here. So insert 460, yes. And I get 633.824 feet. Okay, that's the apothem. Oh, you want to see that other one? Sure. Okay. So if we were using the 36, we'd have tan 36 equals opposite 460.5 over apothem. What would I do here to solve? No worries. Like I've been saying since August, multiply both sides to clear out the fraction. And then we want this alone. They're attached with multiplication. So divide by tan 36 to get apothem by itself. And it turns out that 460.5 divided by 460.5 divided by tan 36 is 460. 460 second insert 0.5 times tan 36. There we go. Whoa. That's not the same number as that. What am I missing? Yeah, hold on a second. I gotta be thinking about this. I think I was just rushing too much just there. Okay, we've got our triangle, we have our 54, we have our 36. We know that this is 460.5, and we're looking for the apothem. So one equation is the tangent of 36 equals 460.5 over apothem. And so apothem is going to be 460.5 divided by tan 36. Oh, I think I multiplied. Yes, I did. 460.5 divided by tan 36. And I end up, yes, finally, with the correct answer this way as well, 633.824 feet. Okay, so that helps me find the apothem. Great. What's left? Well, remember, we're trying to find the area of this pentagon. And our area formula is 1/2 perimeter times apothem. Our perimeter, well, we have 5 sides, and each of them is 921. So 9 times, 5 times 921, and I get 4605. Okay. So we're going to have 1/2 4605 times, what was our apothem? 633.8238744. Okay, so I want that number times 5 times 633.8238 744. All right, and so that's 1,459,379.471, and these are square feet. Now, to give you a sense of that many square feet, tens, thousands, millions, guess what? The Pentagon has a couple of floors to it, huh? To give you a sense that if we're talking about a football field, I believe that's 150 feet. If you're in, yeah, I'm going to go with 100 because I actually think it's 100 here and 300 here. And so we're looking at 30,000 square feet. So take this and divide it by 30,000. Divided by 30,000, and I get 48.6 football fields. That's a lot of space inside of one floor of that office building. Okay. Finding the area of a regular polygon? Yep. Saw in your test. Okay. Next. Oh yeah. So, I don't know if you know this, but I know you know that we had fire in the mountains in the Catalinas this past summer. It made for some really eerie evenings, and some of you, I imagine, were living in an evacuation zone, which kind of sucks. But we also have on the mountain some fire watch towers. So how about Tower 1, Tower 2, and from Tower 1 to the fire, the bearing is north 76 degrees east. And from Tower 2, the bearing is north 56 west. Okay, so this bearing here is north 56 to the west. And this bearing here is north 76 to the east. 76 degrees. Well, here's our question. There's the fire. There's the road between the two towers. The shortest distance is along that perpendicular. So we have the hot shots here, and we want the shortest distance for them to go. Let's call that D. And they'd like to know, how far is it to hike in to go fight that fire? This road is 30 kilometers. And we'd like to find D. These are right triangles. Yeah, this isn't the right triangle. These are the right triangles. And so then the question is, how do we find that distance? So, like the problem we did in the last video, dealing with Mount Lemmon and two triangles, this is kind of a two-triangle problem, huh? So I'm going to call this distance x from here to here. And this whole thing is 30. So how long is this piece? Well, if the whole thing is 30 and I take x away, I can say that this piece is 30 minus x. And now I think I have enough information to draw and label two triangles. I've got this triangle over here with 30 minus x and d. And I've got this triangle over here with x, d, yeah. Do I have enough information? Not yet, because I haven't used the bearing angles. So, if this is a right angle, and that's 76 degrees, that means I have 14 degrees here. So this is 14. And that's 56 degrees, and there's a right angle. So that must be 34 degrees. Now, can you write me an equation for each of these? Sure. So here we're going to have tangent of 14 equals d over 30 minus x. Here we're going to have tangent of 34 equals d over x. And again, I'm going to use substitution and say, I know what d equals. I'm going to plug that into the other equation. Okay, what does that get? Well, it gets me a little algebra. So we've got tan 14 equals, I'm replacing d with x tan 34 over 30 minus x. Okay, how do I solve that? Well, if I multiply both sides by the denominator, and here, I get x tan 34 equals, hey, I want to say something about this. See how I put these parentheses there? I did that for a reason, because often students don't put parentheses, and they multiply the 30 times tan 14, and they do not multiply the x times the tan 14. I'm putting these here as a reminder that I'm going to distribute that tan 14 to both of those. So 30 tan 14 minus x tan 14. All right. And we're going to get all the x stuff on one side. 30 tan 14 equals x tan 34 plus x tan 14. And no, I can't add these together. But I can factor out an x. Tan 34 plus tan 14. No, I still can't add those together. But I can solve this equation for x simply by dividing both sides by tan 34 plus tan 14. Okay, these cancel. X is by itself, and this. My recommendation is that you try typing this in your calculator right now so you can make sure you're comfortable finding it. Because a lot of students think they are, and then when they try it, they actually get the wrong answer. So I'm going to do it and tell you what my answer is so you can check against yours. And then I will tell you what the most common cause for that is. And I end up with x equals 8.096497514 kilometers. Remember, our picture looked like this. This was t, this was 30, this was x, this is 30 minus x. We just found x. That's what we found. But we were looking for this. Remember, when we made our trig equation over here, we said tangent of, was it 34 degrees, equals d over x. So x tan 34 equals d. What's that? Just check. 56. Yes, 34. Okay. So I know what x is. If I multiply x by tangent 34, I can get d. X times tangent 34. And I get that d equals 5.461 kilometers. Okay, 5 kilometers. Yep, that's a lot of stuff to carry. Thank you, forest fighters, for going and fighting our fires. Yeah, that's it. And in the subsequent unit, when we come back and see this problem again, we're going to have these angles up here because this is not a right triangle. Cool. Yeah, 2 triangles. It's going to be there. So please make sure you start thinking about it. Oh, is that 2 triangles? Oh, I know how to do a 2 triangle problem. Okay, this one. The plane is 100 miles, oops, north and 85 miles east of an airport. What bearing will it fly to get to the airport? Now, curiously enough, with this problem, what I see happening on assessments is people draw a triangle, people label the triangle properly, people use the correct trig function, and then they write the answer wrong. Right, completely wrong. So let's see what we've got. We've got an airport, and we know that 85 miles east and 100 miles. This is an Amber Alert. With two kids, two teenagers, seem to have made off in a car. All right, so we've got 85, we've got 120. This is where the plane is. And this is their path home. Now, when I look at this picture, I think if I'm in the plane, I want to head south, something west. And for some reason, when students do this problem, they say they want to find north, something east. I'll grant you that these angles are the same, but the bearings aren't, right? The plane has to go south, something west, not north. So if this plane goes north, something east, they're going further from the airport. The airport's over here. You have to go south, something west. Right, that's the big issue. Here's the angle that we're looking for. How do I find that angle? Well, looks like opposite and adjacent. Tangent of theta is 85 over 120. Now, how do I get tangent alone? Do I divide by the letters, TAN? Only if you want me to lose a little more hair. Stop it. No, that's what inverse trig functions are for. When we're solving for an angle, that's when we're using inverse trig. Well, I've got these two sides, and so I'm looking for that angle. I know I'm using inverse trig. 85 over 120 equals theta. Okay, so inverse tangent. No, not my phone. Pull the other rectangular device. Inverse tangent 85 divided by 120. And I get that theta is 35.311. That figures. So my bearing to get home is south 35.311 degrees west, which is not generally what people write. And then I have to mark it wrong, and we're all sad. So pay attention when you label the picture. And I think what happens is people don't actually put where the plane is and where the airport is. And because of that, they work on I just know that this is a common place where people get completely the wrong answer, even though this is a really straightforward question for us. This is definitely a geometry level difficulty problem. Okay, last one. A nice gentle one. Have you ever been kite flying? Well, I encourage you at some point in your life to go fly kite. We'd like to say something about the height of the kite. We know that 75 feet of string is out, and I've got a 60-degree angle from my hand up to the kite. So how do I do this? I know an angle, I know a side, I'm looking for a side. It's time to use trig. Which trig function would you use? Opposite and hypotenuse. Nice. Sine of 60 equals h over 75. And so if I multiply both sides by 75, I can find the height. Sine of 60 That's like the sign of saying, it's like saying the sign of pi over 3, which is root 3 over 2 times 75. So, 75 times square root of 3 divided by, and I get that the height is 64.952 feet. Remember, this has got to be the longest side, the hypotenuse. Phew, that is shorter. All right, well, I think that's a good start for us on these problems. There's certainly more in the textbook like this, and in our next video, we'll do some more. I'll even see if I can throw in a bearing problem for you, but not in this video, in the next one. Okay, take care, everyone.